something like that. If we have a bunch of data, right? I'm showing it as a bar graph. Right, and let's just call this f of x. And then let's call this x, right? So we have a bunch of data. Okay, and they're just represented as bars. How do we find the average value of this data? And let's see how many, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 pieces of data. How do we find the average value or the mean value of this data? What do we do? What do we do? Add them all up and divide by the number. Exactly. We've been taught that probably since grade 6. So you're going to add them all up, divide by the number. So in this case, we would add up all the heights of the bars, divide by the number of bars. There's 9 bars. And we get it. Let's just do 10 just to make it a nice, easy 10. Okay. So the way that looks mathematically, we're going to sum. Remember, this is the sum symbol. We're going to sum all of the fx values, right? And then we're gonna from n equals 0 or 1, I should say, to 10. So we just means we take value 1 plus value 2 plus value 3 plus value 4. We just take all 10 values, and then we divide it by n, right? The number of terms. I shouldn't use n in 2 places, actually. I'll just, you know what? I'll just do number of terms. Number of terms. Okay. So that's how we find the average value of a function, not of a function, of data, right? So we know how to do that. And we know the average, if you were to graph it, the average would be somewhere like in the middle of all of them, like somewhere over here, right? And when I calculate your marks for stuff, I'm always looking at the average and your average and stuff like that. We always sort of keep that in mind. So my next question is, can we do this for a continuous function? Same thing. Can we do this for a continuous function? So if I have a function like this, right? Let's call that. Let me move my chat. I know you can't see my chat, but it's blocking my view. If you have a function f of x, oops. F of x, it's a continuous function. How do we find the average of this function? Say we wanted to find the average of this function between, we'll call it a and b. How do we find the average of the function? What do we do? You fell into my trap, Anna. So Anna said use average rate of change. That's not what I asked for. Anna's right. If I asked you for the average rate of change, it would just be like this point and this point, right? And you just find the slope between those 2 points. But that's not what I asked for. I mean, I should have written it down. I'm looking for the average, not the average rate of change of the function. I'm looking for the average value of a function. Right? Do you see what I'm saying? So like, what's the average height of this function? It's not the average rate of change. That's something completely different. That's related to the derivative, right? The average rate of change. That's the slope. I don't want the slope. I want the average value. And you might say, oh, can't I just like take the halfway point? That's the other thing that students, you are going to have to use the integral. Yes. So take the halfway point. Can't we just take the halfway point? And the answer is no, that doesn't work either. Because think about it this way. If I really exaggerate this, if I were, let's do it. I'm just going to do an exaggerated one on the side. Say I wanted to find the average of this function, right? Between like this value and this value. The average value of this function. See how the function spends a lot more time up high than down low. So if you just took sort of the average between these 2 points and like the halfway point between them, that doesn't represent the average value of the function, because like these values should be bringing up the average more than this value brings it down. So the average value of function isn't just the halfway point between the high point and the low point either. It's like we have to do here. We have to sum up all the heights of the function and divide by the number of terms. We actually do the same thing. But when we have a continuous function, instead of using the sum, we use an integral. So it's finding the average height of a function. All it is you find the area and you divide by the width. Basically the same thing you do here. Here you're basically finding the area. You're adding up all these things, and then you're dividing by the number of terms. You're dividing by the width. You do the same thing with a continuous function. So it actually, the average value of a function is the integral from a to b of that function with respect to x, with respect to the variable, over the width, which is just a minus or b minus a, how wide it is. That's it. That's all there is to it. So you can use another good application for an integral is to find the average value of a function. So when you do this calculation, you're going to get basically some average height that's going to be like something down here like that, right? That's going to tell you like basically how high the average height is. And if you think about it, it makes sense. What we're essentially doing is we're finding the average or the sum of all the things. So we find a total area and then we divide it by the width to find like the average height. So we're basically turning this into like a rectangle, like that has an equivalent area, right? So that's what we do. So just a very quick example. Let's do an example of, I don't know, average value. If I asked you for the average value of, let's just do something very simple, because I know a lot of you haven't done the practice already. So let's do the average value of x squared between, so let's call it f of x, between x equals 0 to 10, 0 and 10. Okay, so what's the average value of the function x squared between 0 and 10? So x squared between 0 and 10 is going to look something like this, right? If this is 10 over here, this is 0. The mean or the average value between 0 and 10, well, 10 at 10, it's 100, right? So the y coordinate here is going to basically be 100, right? Because 10 squared is 100. So we might expect the average value to be 50, right? Which is halfway in between. Is it going to be that? Well, let's find out. Let's calculate it. Let's calculate the average value. So the average value of the function, the average height of the function, is the integral of f of x, dx between a and b. Or in this case, yeah, let's put the general formula first, and then we'll plug in what we know, b minus a. So the b and a, the things between are 0 and 10, right? So we can replace that with 0 and 10. And the function is x squared dx between 10 minus 0, which is just 10. So what is the integral of this, of the numerator here? What does that evaluate to? Well, if we just do sort of off to the side, we can sort of figure out what the integral of x squared is by itself. What's the integral of x squared? When you take the derivative of what, you get x squared. Again, this is where some of you just need to practice. But can anybody help us out here? What's the integral of this? We increase the power by 1, which is the opposite of what we do when we take the derivative. And what do we do? What's the thing in front? Yeah, 1/3. And we basically divide by that exponent that you raised it, right? Because if we took the derivative of this, we brought the 3 down, it would cancel out with this 3, and then we'd end up with a 2. And the indefinite integral ends up being that plus c. So that's what the integral ends up being. So when we take the definite integral, right, the numerical integral, we're going to do this evaluated at 10 minus this evaluated at 0. So it's going to be, and again, if you haven't done the practice or watched the videos, you may be a bit lost, but you can get caught up. 10 cubed minus 1/3 0 cubed over 10, which ends up being, well, this is going to go away. Oh, sorry. This is going to go away to 0. This 10 is going to cancel it with one of these 10s. So we basically get 100 over 3, which is, it's approximately 33.33, right? Put the approximate symbol. So what that tells us is that the average height of this function between 0 and 10 is actually 33.33. It's not 50. Right? The average value is actually sort of down here. So if we were to squish the area below this curve, if we were to squish the area below this curve into a rectangle, it would look like this. It would actually be lower than, because if you think about it, like this piece over here sort of would fit over here nicely-ish. Well, you'd have to sort of change the shape of it. But essentially what I'm saying is that it's not just the average of the highest and the lowest value. It's the average of all the values along the function. And clearly there's a lot more low values here than there are high values. The lower values are going to have more impact on the average, which is why it's lower than 50, right? The whole point, a quadratic gets bigger faster the bigger the x values go. So there's going to be less bigger values and more smaller values, right? Because it increases slowly at first and then fast later. So it makes sense that it's less than 50. Okay. Does that make sense? We see how we can find the average height of a function. So this is definitely something, I'll actually go back down here. So if anybody that's copying it down can take down that example. I am recording this as well. Any questions about that? Or does that make sense? It's just another application of integrals that we wouldn't be able to do really otherwise. We wouldn't be able to find the average value of the function if we didn't know how to take the integral. So not to be confused with the average rate of change of a function. That's the slope between 2 points, right? And that again is the formula.